Okay, so hello everybody, and welcome to the reverse engineering session 1 for Powershape. Again, the purpose of these presentations is a short, punchy sort of demonstrations showing tips and tricks as to how to use the software to get the most out of it. So let's make a start. And as always, there's an agenda. And on this occasion, the agenda is first of all to talk about model registration. When I travel around the country talking to people, one of the questions I'm quite often asked is how do I go about getting two sets of triangles that have been scanned of the same part that are not in the same alignment. So we'll have a look at the tools that are available there within Powershape to help us. Once we've done that, we'll go and have a look at triangulation of point clouds. Now, more and more these days you receive data in a triangulated format, but there's still a need to turn point clouds into triangles in order that we can go on to either machine them or to reverse engineer over them. I'd just like to give you a few pointers and a few tips and tricks there as to how to be efficient and get the best results. And then I'm going to move on to some surfacing strategies. So this is very much about surfacing over a mesh. There are two distinct types for the simple surfacer, which is to use trimmed surfaces and to use untrimmed, and I'd like to talk a little bit about how, where and when to use those. And then we'll go on to another technique that I find really useful that is a slightly different way of working but gives great results. So I'd like to just show you that and give you that as food for thought. Yeah, and of course, touching on that as well is, and kind of meshed in with the previous topic is that of the smart surfacer, which is the ability to drop a network surface over triangles. So again, we'll touch on that. So let's go and take a look at Powershape. I'll tab through to the right view. And what I've got here is an example where I've got two separate triangle files of the same model that I've read into the same session. And what you can see, if I change the color of one of these, a little tip for you: select the triangle model. If you want to get to the style toolbar these days, right-hand mouse key at the bottom of the screen here, and there's the style toolbar, and we can very easily then go and change one of the models to be a different color. So we can clearly see there two different models. So what I'd like to do is, first of all, select one of these, go to the Manage toolbar, and look to align them. So the first alignment that I'm going to do is what I consider to be a coarse alignment. We've got two very differently positioned models representing the same part that we need to pull into something like the same position. So first of all, Powershape asks me, go and select the alignment item. This is the item that's going to move. So I'll select that. Now go and select the fixed item. And once we have two of them, it's ready for me to go and define the points. So in previous versions, we would go about doing this by trying to find the same points on the same models, and it wasn't always very clear because they're overlapping each other and intersecting with each other and so on. These days, what we can do is split the view, and what that will do is it will pop the alignment item onto the left-hand side and the fixed item onto the right-hand side. What I can then go on to do is to initially align the views, and I'll take a moment just to do that. I'm going to get a view that looks onto that slot there from this direction on the alignment item. I'm going to whiz this one over to give me kind of the same view. It looks like, bear with me while I just do that, something like that. Looks about the same. Shall we say? Yeah, good. So once I've done that, I'm able to go to the menu toolbar again and link the two views. So as soon as I do that, what we see now is the whole process of lining these two. Remember, they are still overlapping each other, but we've been able to split the view to help us go through the process of aligning. Now, the other thing I could do is just say, okay, let's just set the scale to be the same for both of these. So it's just nudge them to be exactly the same scale. Okay, so now we're ready to start to align. And what I'm looking to do here is to go for a minimum of 3 points on each model that can be used to get an alignment between them. It doesn't matter what order you do these in, so I could do all 3 on this side and then all 3 on the other side, or alternate. It's up to me. So here's what looks to be a very similar point, just there and there. So we'll take that on both points. If you don't like the point, no problem. Just click it again. You see the little cross marker on my icon. just click it again and it will disappear and you can re-add it. So there's the first one. Let's go and choose a second point. I'm going to take maybe down towards this corner down here. Looks pretty good. Somewhere down here on this one. And then maybe one a bit further away over the other side of the model. What should we go for? Let's have a look. Yeah, maybe over here somewhere. What have we got there? Something like that corner there, maybe. Okay, so I believe that I've got the 3 points that match each other. So before I commit this, what I'm able to do is go and preview what this model would look like if I were to combine it. And you can see that's pretty good. As an initial alignment, we've got it kind of roughly in position. And yeah, I like that. So let's go with it. So I'm going to commit to that by applying. Now we have the two models coarsely or roughly aligned. And what we can go on to do now is to, again, I'll select the alignment item, go for the Manage toolbar. I can go and do a best fit alignment. Now this is an iterative type algorithm. So what happens here is I can first of all select my item to align, which I already have done, and I've got the tick to say so. Now I can tell it that the item that doesn't move, the fixed item, is the purple one, this one here. And I've got a few options here. I can fill out a few text boxes here. So the first one is what's the maximum initial distance? So what we're really saying here is anything that's beyond this distance in terms of triangles between the two models, any that are further apart from each other than 1 millimeter, consider those not to be involved in the alignment. So clearly over here, you can see this is probably surplus to requirements here, an extra part of the model that we don't have on this other one, so we don't want to try and use it to align because that will give us a false positive. So we don't want to use that. So anything beyond a millimeter will effectively be ignored. Now what we're saying is, okay, so iteratively we're going to try and nudge these into position, and what's the desired fit before the process will stop. Now you can imagine if you put a really, really low number there, there's an awful lot of iterations and we'll be spending an awful lot of time waiting while that happens, while it iteratively goes through. So here I'm going to put a realistic tolerance of, let's say, 0.1. And when I apply that, the iterations occur and the part is nudged. I don't know if you just saw that there, but it was nudged into position. So now what we have is our fine alignment between the two models that we could then, of course, go on to, if I select one of these, let's go for the purple one, go on to, in fact, go for both of them, go on to combine, and then carry on doing work further downstream. Okay, so that's how to go about aligning or registering, as some people call it, multiple models. So the next thing I'm going to talk about is reverse engineering, fitting surfaces over models. So here we have the fuel tank of a motorbike, and I have it as point cloud information because I'd like to talk a little bit about how to go about triangulating over points. You see there's lots and lots of points here. If you zoom out far enough, it almost looks solid, and I'd like to triangulate it. So a little tip for you here is to not try and triangulate the whole thing in one go. So what I'm going to do is select this triangle model, I'm going to copy it and then immediately paste it, take one of the copies and drop it onto layer 0, and then just switch off the original that I had. So if I switch that off, you can see I've got one on layer 10 now, one on layer 0. And the reason I've done that is I'm going to take this point cloud, I'm going to go to the Manage toolbar for the point cloud, and then I'm going to select a region using the continuous lasso, and I'm going to pick a typical region on this. So somewhere around here, looks like a fairly typical area, and I'm just going to grab a swatch of it by lassoing around and then dividing it according to that swatch. So what we now have is a localized swatch that represents a typical cross-section of the point, spacing and so on that I can work with to get my settings. Now on small triangle sets or point clouds, it's not really a big deal, but if you've got larger point clouds, you don't want to be sitting around waiting for it to calculate over the whole model when maybe the numbers that you're going to use aren't quite right. So then what I'm going to do is take a quick look and get a feel for the typical point spacing on a model like this. So if I just go for wireframe, that's probably the quickest way. Go for a non-continuous line. You're looking at 1.9 there, and then maybe once more, let's have a look. What is it here? So 2.5. So sort of 2.5 is fairly typical of the point spacing, maybe a bit bigger in places, a bit less in others. And then I could go on to have a look at how big gaps are and so on and measure those. So once I've done that, I'd like to go and create my mesh. And if I leave the whole diameter at the defaults that have been suggested here and hit OK, we're going to get a result over this. Let's take a look what we get. I'll take the mesh, and what I'll do is I'll just drag it out to the side here so we can see a mesh there, some faceting going on there. Ultimately, at the end of the day, you can only work with the number of points you've got. You can always filter out the points to have less, but you can't effectively add more. So we're always at the limitation of how accurately or how much data was taken when it was originally scanned, but we can work within that to get the best results possible. So let's take a look again. I'm going to take that point cloud and select it once more. And this time I'm going to mesh it. But remember, the setting that I said was typically about 2.5 millimeters there for the point spacing. So let's set that as 2.5 mil as the point spacing side. And then the hole fill, I'm going to suggest it's something like 15 millimeters for the hole fill. Let's click OK to that. So again, we get a triangulated model. And as before, what I'm going to do is grab that mesh and I'm going to drag it out to the side. Let's try and wake up a key point so that we've got some sort of reference. There we go. And if we look at that, we can see that, I don't know if you can see that yourselves over the web, but clearly on my screen, I'm getting a much better quality of triangle set to the one that we originally went for just here. So let's do it once more. And this time I'm going to suggest that my mesh size is 0.5 millimeter. And my hole fill size is probably the same, let's say 15. Actually, I'll go a bit lower here this time. I'll go 5 and click OK. So now let's take that mesh. In fact, what I'll do is I'll select the cloud itself and just delete that. So what can we see? Well, we can see that the hole fill hasn't been as successful. So there are areas where 5 millimeter didn't quite close off the gaps where the point spacing is bigger than the 2.5 that we, or the 0.5 that we went for. And we can see, again, I don't know if you can tell that, but there isn't really any improvement in those triangle models from the one that I went for where I measured a few values to the one where I've just gone crazy with the step over and use a really small value. But if I were to go for the selection information on this one, we're looking at 17,000 triangles roughly on the one that I did. The one where we've used really small values, 37,000 triangles. So getting off a double the amount of data with no real improvement in the triangulation compared to the original one where we used the defaults, and that was 1,800 triangles. So there's always a trade-off, but the good balance point is where we've measured a few key sizes to get the numbers. So cast your mind back to the entire model. Let's delete that and go to the original, which is on layer 10. I could, of course, select this and now apply my values that I know are going to be good. 2.5, what did I say, 15? Click OK to that. And off we go, triangulating this model. And you can see this will take longer because there's more triangle points, but we've done all of the initial sort of work to figure out what our best settings are without the overhead of the time constraint. So now we can look at the mesh, and yeah, all is good. Excellent. So we've got our mesh. Now I want to go about breaking this into half because I don't want to necessarily model left and right. It's symmetrical over the center line, so I can split it. And again, it's perfectly possible to limit triangle models to wireframe geometry. And that's important to mention because I'll be sort of referencing that further downstream in the demonstration. So let's show you how you go about doing that. I'm going to create some wireframe, and what would make sense for me here is to create an arc through 3 points, a fitted arc. I just snap to 3 points that represent the top center of this tank. That gives me a center point that I can then go on to use a line to capture the center line of the part. Then having done that, I can go to the edit toolbar. I can ask to limit by projecting. Now you can either go straight to the item that you want here, so that's projecting down a view, or what you can just do is click it until you get the one that you want appear in the toolbar. That's the one I want. Limit to a view, and then simply click the item that I want to limit. And the part is limited. If you wanted the other side, no problem. Don't forget just to go for the next solution on that toolbar. While we're here, I'm going to just show you how to do it again to another piece of geometry. I'll go for a full circle there, and let's drag the handles out on that to be just beyond, somewhere around here, shall we say. Of course, I could go for a sensible radius if I wanted, but that's fine. Okay, so having got that, again, we can just go to the limit command, toggle through till we get the view option in this case, and then click the item. Beautiful. So let's select that information. I don't really need that anymore. And that leaves me with a model that I'd like to go on to reverse engineer. So if I select the triangles and go for the Manage toolbar, on the left-hand side here, we've got a pull down that's got different types of surfaces. Now for this session, I'm going to be looking at the From Mesh option. So if I click that, the toolbar pops up. And the first thing to note is that the first icon controls whether I've got a trimmed or an untrimmed surface. So that's non-trimmed, it expects 4 corners. Trimmed, I can have as many corners as I want and it will deal with it by trimming out the region that I need. So on this occasion, that's the one that I want. The next thing to mention is that we've got this tolerance here. And the tolerance is separate to the tolerance that we're working to down here. This is our general working tolerance for most commands like filleting and so on. But for creating surfaces over a mesh, I can independently control that and say this is actually the tolerance that I want to work to. So yeah, I've got 0.5 mil set here, that's fine. So now what I can do in this mode is go and click an initial start point. And if I click extra points without holding any shift keys down or anything like that, so I'm just clicking with the left-hand mouse key, what I get is intermediate points that help the flow of the curve until I come to another corner point where I can hold the shift key down and click that as a corner point. And you can see that it's gone red on this occasion here for this edge. And I've got a little yellow dot to say I've now got a corner point. And of course, I can then, without the shift key held down, walk around and add in, with the shift key now, another corner point. And I can do this to my heart's content around the model. We'll do it again here, to here, to here, round to here. And on this occasion, yeah, if I just pop it in about there, I'm not worried about, you see that little curve going on there? Not worried, because when I hold the shift key down and click, Powershape will deal with that for me. And again, I can walk it over an edge to another corner point just here. It sees the green there to denote that I'm on the edge of the triangle set. So it's just to let me know that I'm on the edge of the triangle set, and it will hold the tangency of the surface there to the edge of the triangles, round to here, and then again over to here. Likewise, over the edge just here, so this is without the shift key held down, I'm just walking it around to give it some guidance as to where I want to go down this edge, around here somewhere, and then another point just about there, shall we say. Walk it around to there for another corner point, and then up and over. If you do want a corner point and you didn't select it, no problem. At the point where you want it to be a corner point, just go and click that button here, and that will turn it into a corner point. I won't do that on that occasion because I don't want a corner there, but that's how you would do that. And then all I do is get back to the start. When you get back to the start, you'll either get key point or you'll get that little circle going on there. If you can just see that little circle, that tells me I'm back to the beginning. When I click that, Powershape will go and make sense of the region that I've asked for and fit a surface to that. Now it fits a very smooth type of surface to that, a NURB, a non-uniform rational B-spline surface to that region. And of course I can use the shading here to see how we're performing and then walk over it. And you can see the general fit here is really good. So I asked for a 0.5 fit and I'm getting much less than that, you can see. It's all good. Okay, so moving on, I'd like to do this region just here. And as before, I can go and click a point and walk it up and over, something like this. And you can see I'm generally following the horizon edge of the fillet. And the other important point to notice is that, again, it's up to you how you work, but I find that doing the large, sweeping, gentle surfaces first, so the large regions first, and then coming on to do the fillets afterwards gives me the best results. So this is how I choose to do these regions. So I've got an endpoint there, yeah, just there, and I wanted that to be a corner, but I forgot to hold the shift key down. So I can just hit the create corner there, and that will deal with it, and then I can carry on and walk around where I want it to go for the next region. So again, I'm holding the shift key down. It doesn't matter here really, but I can just hit without the shift key because it's an endpoint, and we'll get a surface that closes that region off. I quite like to use the F4 key when doing this kind of work because F4 changes the shading view to be shaded but semi-translucent, so I can really see clearly the edges of the surface while still seeing the triangle set. So that was the F4 key. To toggle back, of course, just go back and hit F4, or F3 will give you the original solid view. Okay, so now I'd like to put a fillet that really combines these two. And for this, I choose to use a non-trimmed surface because the difference here is we're not using trimming data over a large blanket to get the edge. We're actually using the edge of the surface itself, and that gives us a much better match to surrounding surfaces. So again, my working method is to put the large blanket surfaces in using NURBS, trimmed regions, which are really, really smooth, and then connect those together using non-trimmed surfaces, which can really hold the edge of the surrounding surfaces as good as I want it to be. And as before, what I do is I hit a corner point. I walk over to the next corner point. I'm going to hold the shift key down and click again. Do you notice that we get a green edge to say, once again, we're tangent, and Powershape has realized we want to travel all the way around the edge of this surface without me having to click it to get to the other side. So then I can walk around and click some other points, click with the shift key held down, click this corner point. Now here, I'm going to simply click one point so that it knows which side of this surface to go around. And then I'm going to come back down to this corner point with the shift key held down. I now have my 4 corner points for this style of surface. When I click back to the beginning there, you can see that circle. It closes it off and fits my surface to that region. Okay. So I'm going to finish that off, and you can see we've got our surfaces fitted to that region. And again, I'll hide the triangles for a moment, and you can see we've got our surfaces going on around there that fit surfaces in that region. One thing you'll notice is it's added the points to tolerance, so it's inserted these internals according to a tolerance that I specified. But what I can always do is go to this surface, go to the Manage page, and I can look to approximate. And what this does is it looks at the surface again and reapproximates it once more to the tolerance that I'm working to. So I'm currently working to a tolerance at the bottom here of 0.05. When I hit approximate, what it will do is remove any extra curves that aren't required to this tolerance. And you can see that's just taken out a bit of that information. So we've got a pretty good result there to reverse engineer that region. Okay, so that's one way of working, and that was the, let's unblank those triangles. That was the, just to recap there, from mesh mode. But there's another way of working here that I'd like to show you. And I'm going to just select those surfaces. Let's pop those out of the way for a minute. Draw the triangles back up. Because what we can do is, using the techniques that you saw earlier where I limited this region here and limited, what else did I limit? Oh, I limited the halfway marker on the triangle set. I could draw in some wireframe for the regions that I want to surface as those large blankets. And what I can then have are effectively triangles that represent the entire model, but broken into segments. So you can see here, I'll just draw one of them. That's that initial segment where I've limited out using the limit command on the edit toolbar and some wireframe, the region that I'd like to surface. And the reason I've done that is because now what I can do is select that surface. Under the Manage toolbar, I can go for Shrink Wrap. When I click the Shrink Wrap surface, I don't have to go around clicking edges necessarily. It will automatically drop a NURB over that region. So I'm going to click OK to that. There's more I can talk about here, but I won't do that just yet. So I immediately have a surface over that region. Now let's look at the next region. excuse me, I'm sorry, I'm in the wrong place there. There we go. That's the next region there. Again, I'm going to shrink wrap over that. Excellent. Let's go for another region, which I've chopped out just here, and let's look in more detail at this region and what we can do. So, shrink wrap, preview. If I were to go for the F4 key, can you see the alignment that's been chosen for the internals on this surface? Well, if I was modeling it, I'd rather have the alignment kind of parallel to what is a fillet here. So what I can do is grab these handles that are the edges of this surface, and I can drag it around to kind of visually align it with the direction that I'd like that surface to go. And of course, again, if I feel that I need a higher degree of fit, I can drag these U and V fit values upwards to give me more internals on the surface. When I click OK to that, I now have a surface for that region. Let's just do a couple more. Got another one here. Let's grab that. Drop a surface over that. I'll go with the defaults, that's fine. And then another one just here. So very quickly, I've been able to really model the vast majority of this fuel tank with minimum effort, really. And all that leaves then is the fillet regions. So with the fillet regions, I could go back and use the simple surface command, the from mesh command to achieve that, or I could use a different strategy. I'm going to show you that now because there are some advantages to it. So what I won't do is I won't use the triangle set that I've limited, just to show you what I mean. That's the one that's been chopped out. I won't use that because I don't want the edges here to confuse when I fit the surface effectively which edge of the surface of the triangles I'm trying to use and which direction the tangency goes off the triangles. So what I'll do is use the original before I limited, on this page here. So just to be clear, what I've got is the original triangle set without any limiting, and I've got those new surfaces that I created. I'm going to select that triangle set and ask to create a snapped curve over those triangles. So that was from the manage page, just to do that again so you know where that is. Select the triangles, go for the manage page, and then snap curve. So the important difference here is it will add points to make sure it stays within this tolerance of these triangles. Again, you can take a little bit longer drawing it than I did there, but it's good enough. So I'll click here, round to here, and then click an endpoint, and that will finish the curve. And then I'm just going to add a couple of curves in here to help Powershape in those regions with a little bit of wireframe. So let's have one there, one here, maybe one over here somewhere. Should be good enough. There we go. So just a few extra internals. And then I'm going to ask for a composite curve around this edge. So let's quickly record around, and this is important because I'm grabbing the edge of the surfaces and I'm grabbing the topology, the information about the tangencies and so on from the edge of the surfaces as we go round. At the same time, it knows that we're on a triangle set. So when I select these internals as well, what we basically have selected now is that wireframe composite curve around the edge and these internal curves that I drew over the triangles. Now when I go for a surface and ask for a smart surface, look what happens. We get a surface that's a network over triangles, so Powershape knows all about the triangles that are underneath here, but what it's also done is given us a really nice uniform point spacing for this surface. So this is exactly what I would like to see when I'm surfacing. And the reason it's done that is because it's fitted it to the tolerance that I've asked for and then done a repoint here in order to achieve a nice uniform spacing. Okay, so again, when we look at that, we can see that we've got a really nice surface in that region. I'll go on and just do one more maybe. Let's go for an F4 view here. And quickly draw some curves over just to repeat this process so you understand it. So again, I'm going to select the triangle set. I'm going to ask to create a curve from the edge of this surface. Let's walk it down. I want to kind of follow this direction here down onto that bottom edge. Let's just make sure I get the edge that I want just there. And then I'd like another curve, and what I'll do is I'll go from this area here down onto there. Again, because we're drawing a curve directly over the triangles, I don't have to worry that I'm only selecting 2 points, because if Powershape feels it needs more intermediate points to stay on the triangles, it will add them. Likewise here, down to here. Yeah, good enough. And then maybe one more here down to here, let's say. Just maybe through an intermediate point just there, let's say, about there, good. So then I just need my composite curve around the edge. So again, to achieve that, we'll go for the wireframe toolbar, we'll go for a composite curve, click an edge. So now we're composite curving around the edge of the triangles, onto the curve we constructed, onto the surface that was over the triangles, around the one that we created a moment ago, onto the other surface, to the end here. I must have 2 items. You see that I'm getting that kind of stepped motion there? That kind of tells me that there's probably 2 items there that I don't know about. So I'm not going to keep that. Let's just see what I've got there. Oh yeah, the old composite curve. I'll get rid of that. I don't need that. So just repeat that. Turn it around. Got this edge here. Onto this edge here, along here. Down. And then we'll just go straight on at every junction here until we get back to the start. Beautiful. Record that, finish that command, and then simply select those extra internals that just control how I want the surface to flow in these particular regions, just there and there. So I've got all of that. All I do now is go for my surface command and ask to smart surface over that. And then, of course, we'll get the surface that we want. Network over triangles. There we go. Beautiful. Okay, so I'm going to stop there. This is just to give you a sort of an initial idea as to some of the techniques that you may or may not have been aware of as to how you can go about surfacing and reverse engineering over triangles using Powershape. As I say, there will be more reverse engineering sessions because there's a lot more I can talk about as to what we can do here. But for this session, I'm going to finish there. Let's just recap on what we've seen today. So we've seen how to register multiple triangle sets over a model. We've seen how we can combine those using the split view and very easily coarsely align those and then fine tune them with the iterative alignment afterwards. We went on to talk about how to get the most out of triangulating point clouds and how to do that efficiently when you've got very large files that you're trying to triangulate. We looked at surfacing from a mesh and some of the tools there. So using trimmed surfaces for those large curving areas, gently curving areas, and then using the untrimmed surfaces to close the edges off. So effectively do the fillets. But then we looked at a completely different way of working with that, which was to actually limit the triangles into patches first, and then shrink wrap the surfaces over those regions, and then use the smart surfacer with network over triangles to create the fillet in between afterwards. Okay, so hopefully that's given you an insight into some of the tools that are available there for reverse engineering over triangle models with Powershape. All that remains is to thank you very much for taking the time today to come and visit and watch this session. Of course, we will add this onto the website so you can watch this at your leisure afterwards. Any questions that have come from this session, one of my colleagues is making a note of those, and of course we'll answer, as usual, those questions after the session. Thank you very much, and again, thank you for watching.